Hey everybody, welcome to the OpenUSD Insiders live stream. Very happy to have you with us today. My name is Edmar. I'm from the NVIDIA Omniverse community team. I'm joined by my wonderful partner in crime here, Eric Bowman, aka Strainflow. Eric, this is the perfect live stream for you especially, because
Yes.
we're going to be diving into some really cool, innovative robotic projects that were put together at a recent hackathon called the LeRobot Global Hackathon.
Yeah.
We have two teams with us today, actually, who placed in one of the top 30 places of the global hackathon. They're going to go through their project from start to finish. It is going to be really awesome to see all these projects, and you're going to take your questions live throughout the hour. So everybody watching in the comments, you are part of the show too. So please feel free to post your questions. Let us know where you're watching from. If you work on any cool robotics projects, feel free to post away in there. We're going to take a pause throughout the live stream and answer those as best as we can. Otherwise, we'll try to do a lightning round at the end and get through as many questions as possible. We're also going to have a thread on our Discord server. So if you're not a member of our Discord server, you should join today, discord.gg/NVIDIA Omniverse. And then we have an area for live streams, and you'll see a thread for this specific live stream where you can ask questions or comment about it anytime. Even if you're not watching this live, you can post questions there next week, and we'll keep an eye on it. Before we get started, a couple of quick things. One is this a major event that's happening in literally just a couple of weeks, August 10th through 14th in Vancouver, Canada. Really exciting. This is SIGGRAPH 2025, where some of the world's greatest minds present latest in research focused on graphics. And obviously, we're going to hear a lot about physical AI. We have a lot of great content planned on the NVIDIA side at SIGGRAPH, along with content from lots of great companies and individual and scientists, research scientists around the world. I highly recommend, if it's an event you can get to locally, we actually have a coupon code we'll put in the chat, which gives you free Expo Pass, as well as a few other benefits too. But if you can't make it there, you can actually watch some of the sessions live on live stream. This QR code will bring you right to that page describing the sessions, the special addresses that are available to everybody globally. This is going to be a fantastic event on August 11th at 4 p.m. Pacific. I highly recommend everybody tune in. This is where you're going to find out the most exciting stuff that NVIDIA wants to share with the world. We also have a super exciting day planned around OpenUSD. People who have come to past events will know this usually incorporates some amazing sessions, very insightful sessions from some of our elites around OpenUSD throughout the day. And we also have a meetup that's happening, kind of like a mixer, which is a nice evening event happening as well. So check out that OpenUSD page for more information. And then Amelia has set up an amazing resource for people who are going to be at SIGGRAPH, and that is a WhatsApp group. We found this to be super helpful for on-site visitors. It allows us to kind of chat in real time, let you know what's going on, what sessions you should run over to. If people want to get together for a coffee or a drink, that the WhatsApp group is perfect for that. So we hope that if you're coming to SIGGRAPH, you'll join this WhatsApp group so we can start talking about it as early as now. And if you are going and need any help, we're here for that too. Feel free to hit me up on LinkedIn. You can go to my LinkedIn page by going to edmar.net. And these are some of our QR codes, which will bring you some evergreen resources, our events page listing our live streams, study groups, and our office hours, our official forums, our Discord server, which I mentioned, and our community page, which lists our ambassadors. We'll bring up the slide a little bit later in the presentation, but I do want to actually get the party started because we have a lot to talk about. Eric, are you excited about today?
So excited.
This is going to be cool.
I mean, you've got two groups of people who in like, what was it, 48 hours? I mean, it was certainly less than, it was like less than 48 hours or less, used NVIDIA tech and this really cool open source hardware to teach this robotic arm to do kind of interesting things. And yeah, it just shows, it's this moment where you'll realize how much the bar has been lowered to get into robotics.
Before I bring in both teams, one of the teams has prepared a really cool video showcasing their experience at the hackathon. Let me play this first because I think this really sets the mood for the whole live stream. Let me bring us down. We'll play this video and we'll be right back in about a minute. Amazing. Wow, I got goosebumps watching that. What a great time that looks like. Thank you so much for putting that together. Devon sent that a little bit before today. Okay, so right now we're going to get the party started. Again, this is a very special live stream featuring 2 winning teams from the LeRobot Worldwide Hackathon, teams that did Spice Terminator and LeDetective DaVinci. We're going to learn how these teams use Groot N1.5 and the SL101 robot arm to build AI-powered systems that understand natural language and perform complex real-world tasks. Let's bring them in right now. Here we go. Look at this, all getting warped in. Hello, developers. How are you doing?
Really good.
I'm so glad to have you. Let's do a quick round of introductions. I think everybody knows who Eric and I are. Sahib, why don't you start us off?
Yeah, so my name is Sohaib. I'm based in Munich, Accenture, and my primary expertise is also within mobile robots, also ROS. So I have been introduced to a couple of things in robotics division as well, also simulation within Isaac Sim, Isaac Lab. But this was the first time that I was working with a robotic arm. So it was a pretty good experience, pretty interesting, a lot of pressure within hackathons, but we managed well. So yeah, that's all.
I should say so. That's awesome. I'm so glad you guys are here. And here you brought your partner here, Devang. Hey, Devang.
Hi, Eric. Hi, Edmar. Hi. Thank you so much once again for having me. So I studied robotic systems engineering as my master's, and I'm working with Accenture now. And at Accenture, I'm working with Franca Amica, the robotic arm, and using NVIDIA's foundation pose models, imitation learning, and developing smart gloves. So things like that. So how we can bring robots and humans together, and also working on some automation of software development testing activities. So yeah, that's my experience. And like Sohaib said, this hackathon was really special. It was a very, very cool experience. And I'm looking forward to sharing with all of you what we learned, what we did. So
of course, we're very honored to have you here. Everyone's here for a big treat. Okay, so let's go start with the next team. Sanan, welcome from the University College London.
Hello, everyone. Thanks for joining us. So I'm Sanan Garev. I'm currently studying, I'm doing my master's in robotics and artificial intelligence at UCL, University College London. Right now, I'm based in London. So before my master's, when I completed my bachelor's, I worked as an AI engineer in one of the world lead defense industry companies called Baykar Technologies. So yeah, today we will be presenting our project using the SL101 arm on the cleaner robot. Then we will discuss about that.
Awesome. I can't wait. I've had a really fun time in the warm-ups we've had with both teams. And you have your colleague here. Okay, how are you doing?
Hello, everyone. My name is Pulkit Gera. I'm currently an applied scientist intern at Flawless AI, where we work on visual dubbing of movie assets. Prior to that, I have experience with 3D vision and relighting of assets. And this was my first experience working with robots and physical embodiments. And it was an awesome experience. And looking forward to sharing our insights and our experience with you guys.
Well, we're so grateful to have you here. I think let's talk about the hackathon just overall to start with, so people can kind of understand what the LeRobot Hackathon was all about. So first, tell us, so it was a 2-day hackathon, correct?
That's right.
So you had 48 hours. And what did that mean realistically? So were you guys all in the same space for 48 hours, or did you guys have a certain amount of hours and for over 2 days you were able to access? What was it the logistics like?
I think I'll take that question. So we started on Saturday morning, and we had to give our final working demonstrations and pitch our ideas on Sunday afternoon. So it's like even less than 2 days. I would say 1.5 effective working day. So yes, some of us decided to stay overnight and just remember our university days when, the nights were the most fun parts to do what you want to do and feel this liberal experience of getting involved with such stuff. So yeah, there was a very short time crunch, and many of us were working with this hardware for the very first time out of the box.
Wow.
So not that we are trained on it or something like this. So we just get this at Saturday morning. We're like, what can we do with it? And then Sunday afternoon.
That's amazing. And what was the challenge of the hackathon? What was the goal from the LeRobot's perspective?
So basically it was to really see how much can we push this hardware, this open source that they have, and what creative ideas can come out of this. So bringing in people who are enthusiastic. There were 3,300 plus participants all over the world as far as, and this is more than 40 countries on 100 plus locations. So much young talent trying to see what they can achieve with this hardware, I guess. And imitation learning, of course, and training models, generating data sets. This is everything that was going on in that weekend. A lot of fun stuff.
And did all the teams know each other beforehand, or did you all get paired up at the on-site event?
Sure.
Yeah. We got paired up. So Friday evening we had a official kickoff, and then there were a lot of people who did not even have teams. Me and Devang, we basically decided that we were going to go together, and we had a robotic arm. And then so there were a lot of ideas moving around in the whole space during the networking session, and we talked to people. So some of the people were interested in our idea, and we were also interested in another idea. So we basically jumped ship and got on boarded with another idea of our teammate. And then this is how everything was working there, making teams on the spot. Some of the teams, they were already complete. They had their idea. They were already building on top of it. But yeah, generally it was more or less like socializing, networking, exchanging ideas. Whichever one was clicked with other people the most, they just joined that team. Yeah.
Amazing. And how many people per team?
The maximum was like 5 people. Mm-hmm. So we were ourselves were also 5 people.
Okay.
Yeah, and minimum it can also be 1. There was one guy who was
just a single
one-man army participating in it.
Very cool. That's awesome. And what about the hardware itself? You said this is the first time you had worked with the robotic arm, right? The SL101?
Yeah.
So that was provided for you by the hackathon organizers?
Yes. So all the people who did not have hardware were provided hardware from Hugging Face. So they basically arranged everything, 3D printed, assembled everything, and then also provided to all the teams that did not have hardware. We and our team had hardware, except we had like more than we needed as well, like 4 pairs of arm. But yeah, so some teams had it, some teams did not have it. So everyone just pitched in. So it worked
very
out.
Cool.
Yeah.
Just to chime in really quickly.
Yeah.
So in our London hackathon, a lot of people, there were like a couple of 3D printers that people were printing, and there were a lot of unique ways people were combining. For our team, 2 of our teammates had the one had SO100 embodiment and SO101 embodiment, and we also luckily had access to Intel RealSense camera. So using all of that, we were able to cook up something that we are very proud of.
That's very cool. And so your team also had 5 people?
Yes.
Okay, great. So great. So we're so lucky. We have 2 people from each team here. And you guys were at different locations, obviously, we just said, right? London and Munich?
Yeah.
Very cool. All right. So let's now everybody I think has a good sense of what the scene looked like. Let's do a dive into what each team actually accomplished, because you guys leverage some really cool technology, including vision language. And obviously we've been talking a lot in the last few months about the SO100 and the 101 arm. We've been bringing Rob Knight into the conversation a couple times, including on yesterday's live stream. So I think a lot of people watching this are probably familiar with the robot arm. They're going to be really excited to see what you guys did with it, given this amount of time. I have to say, I personally was really blown away by what you guys accomplished in just 2 days with a small team. And it really opened my eyes to the possibilities when you have even larger teams and larger budgets and time. What's going to be possible? It is very clear, especially to people working in the industry, but now it'll probably be clear to everybody that we are really at the cusp of some amazing robotic development and stories and opportunities and use cases all over the world. I think people are going to get a sneak peek at that by watching this today. All right, so let's get started. I think, Devang, you're going to kick things off, right?
Yes, that's right. Absolutely. Shoaib, please, if you can start the screen share, then we'll.
Okay, well, they're getting the screen share started. We want to invite everyone to post your comments and questions in the live chat if you're watching live. We are going to kind of take these along the way. Let me see. Okay, I don't see your screen just yet. Oh wait, I see it's coming up right now. There we go.
It should
All
be.
right. Yes, I think I see it. We're good to go. All right. Thank you so much, Shoaib, and welcome once again, everyone, to our entire audience. And I'm very happy to share with you our experience with this project, which we call LeDetective DaVinci. And as you can see from this image, you might get some ideas. So our team members, it's me, Devang. Then I have Mohammed Shoaib with me, Arthur, Shakrulo, and Philip. The three of us are not joining right now, but yeah. So this is our team. Let's start. We just talked about it. Eric mentioned there are some barriers that students, hobbyists, and starters are facing at the moment when we talk about entering into robotics. What are those? So getting hardware is like difficult, and lack of hardware means lack of data sets. And without good data set, it's difficult to train AI models. So theoretically, even when I was doing my master's, I read about different types of AI algorithms and models, reinforcement learning and all this stuff, but most of it was just academic knowledge. So to bring it to something physical, something tangible is still a challenge. And then for an individual, there's difficulties in finding a community where you can collaborate, find answers to your questions and all this kind of stuff. And programming robots is a bit difficult and different from just your general software coding. So it's interesting. Today, we would like to showcase or share how today all these barriers are being strategically brought down and how it's becoming more and more easy for young ones like you and me to get into robotics and do something hands-on. So yes. So we already had a short discussion about the hackathon, but just to summarize it once again, LeRobot organized this amazing event, which was with 3,000 plus people from 100 plus different locations. And what was the task? You form team with complete strangers, you exchange ideas, you generate something creative, you design the solution, you implement it. And of course, there's going to be a lot of bugs. So you have to do a lot of debugging on the spot. And then in a few hours, you present a working demo and pitch your idea to the jury and to the audience. So that's what the hackathon was about. So what we started, what was the idea? So we started with the voice prompt, and a user can say something, give a task, which is then converted to a text. And this text is then converted with some with GPT model into an image. It's like a vector image. I'll show you in the next slide. So it's a solid background image with lines on it. And you can say, draw me a cat, draw me a house. And that image will then be converted into a trajectory for a robot. This trajectory is then forwarded to, let's call robot A. We have two robots working in tandem in this project. So one of them is the one that's the detective, the drawing Da Vinci, the artist. So what he does is, based on the trajectory that is received, it draws the, using inverse kinematic, it draws the image. And then we used a robot B, which is trained with NVIDIA's amazing Groot model and imitation learning. It can detect a sponge lying on the surface, grab it, pick it up, and then see where the drawing is and start to wipe it off so that we have more space to draw new images back to back. So this is our idea that we want to implement. So what does this trajectory looks like? So for example, I asked, hey, can you draw me a house? So this is the vector image we get. We extract using Kenny edge detector the edges out of it. Then we get the contour.
What image model did you use to create these images? Just curious.
We use GPT 4.1.
Oh, okay.
Yeah. And then this is converted to the coordinates, as you see on the right-hand side, and these coordinates are being plugged to the robot. Now, when we say robot is generally a very big term. Like we said, it's difficult to get hands-on to a robot or something that can draw for you. And that's where the next slide comes in, this amazing open source hardware. If you can go, the Hugging Face LeRobot SO 101 or 100 arms. So these are open source hardware, very affordable, and they can be 3D printed. All you have to do is just purchase the electronics, so some servo motors and some controllers. And one of the barriers that I mentioned is the lack of community, right? This is where you get an incredible community with huge amount of data set. You can reach out to a lot of people, and this comes from the Hugging Face ecosystem. So this is really a game changer. This is what it looks like, the image. And for the people who are not aware with teleoperation, let's say I want to tell you guys, you see there's an orange and the yellow colored robot. So one is the leader and the other one is a follower. So if you hold the yellow one and you move it around, you lead it, and the other one will exactly mirror your or imitate your movement. So you can use this called teleoperation, and we can use this to teach the robot to do different types of tasks that we'll look into some next slides. So this is something about LeRobot. And I think I will ask Sohaib to take us through Phosphobot and what it is.
Yeah. So Phosphobot is basically like an open source platform for aspiring roboticists and ML engineers or software engineers who want to work and experiment with robots, but they don't have a lot of technical know-how of how to start, where to look for, what is the data collection process, how do I train models. So it basically gives you the ability to control your robots and record data sets in like minutes. Like that was also one of our goals, that during the hackathon, since we were on a time crunch, we wanted something that could help us iterate faster, prototype faster, experiment faster as well. It's compatible with the LeRobot open source arms and also some other arm robotics as well. It has a really nice dev-friendly API as well, and it's compatible with LeRobot datasets as well, because they have a specific format in the dataset. What I'll do is actually I'll go over, I'll give like a small demo of what the Phosphobot interface looks like. So you can start this locally in your terminal. So it has a CLI, so you can basically just run Phosphobot and install it on any system, Mac OS, Windows, Linux, it does not matter. And then you can also see here that you have to sign in. You can also sign in, or you can also not sign in. If you don't sign in, then you don't have these data sets that you record in your own Hugging Face space. But other than that, it's pretty easy to do a lot of stuff with the robotic arm without having a lot of technical knowledge, as well as a lot of installations. It basically takes all of that complexity away from you. You can control your robot via different teleoperation methods. You can control it via a gamepad controller, via keyboard. You can also do it with your hands. So you can capture it with the webcam, and then you can control the robotic arm with the hand as well. Then you can also record the data sets, which is very vital when it comes to reinforcement learning, imitation learning problems, when you have to train your robots. And when you basically record all of your data sets, it basically comes up in your dataset catalog. It can be local. It can also be published to your Hugging Face space, which can then be used for training the models as well. And it's also very easy to calibrate your robot as well, since when you take it out of the box, you need to calibrate a little bit so that each joint is in its right position, and you can then start to move it around. So it's very easy to do this via the Phosphobot platform. We also discovered this during the hackathon. One of our teammates introduced it to us, and it basically cut off all the complexity from a novice like me who did not work with robotic arms before. So it's pretty fun. It's pretty easy to use.
And do you get this from phospho.io, or where did you get Phosphobot?
Okay, so I have a QR code here as well. If anyone wants to look it up, it's phosphobot.ai. I think the link.
Shout out to Arthur.
Yeah, shout out to our teammate Arthur, who basically introduced
Phospho.ai. Yeah, I'm just looking, and
yeah, they also provide hardware options as well.
You can buy arms from them. They've got some software helpers. That's pretty nice. It's good stuff.
Yeah, they also have a really good API documentation for them, which is very extensive. You can basically just go through it, and it's very easy to get hands-on experience as soon as you go to the developer API documentation as well.
Yeah, I was actually looking on their website, and I can't find it now, but they've got a testimonial from Lychee, from our a common guest here on our live stream. So that's kind of fun.
Yeah, Lychee has been doing really good work for the community. Yeah. It's pretty amazing.
Oh, here it is. Yeah.
Yeah.
Under their starter pack.
Yeah.
Anyway.
Okay, yeah, that was an introduction to Phosphobot. I wanted to mention it because there are a lot of people who want to experiment really fastly with these robots, and this is a pretty good platform to do that. And then after we record some data sets, you can also visualize your data set in the LeRobot data visualizer. And it looks something like this, where you have all the episodes, you have all the values of the motors, and you also get the observation of the images that are captured when you are recording the data set. So it's a pretty nice visualizer just to see how your data set looks like and what can you extract from it and how it will go into the training data for the AI model. So that's also pretty handy. And this is also from LeRobot, so it's open source. So that's also very, very helpful while you're doing a lot of experimentation.
I think it's so impressive that you're working with soft bodies here.
Yeah.
A lot of people really have a hard time with soft bodies, and here you have a very inexpensive manipulator, and you're training it to work with soft bodies in less than 2 days.
That's where the power of Groot comes in.
Yeah, it's really cool.
You just need very few training, I would say, epochs to basically fine tune it for specialized tasks, which is pretty good, pretty awesome. And that brings me to our next slide.
Just one tip for the audience that I would like to share here in this last slide, that you saw there are two cameras. So one was the eye, which is on the arm itself, the gripper itself on the left-hand side. And the second one is the contextual camera. So it gives the whole scene. So if you are training, or if you would want to train a reliable model, I would recommend to use two cameras, because some of the teams, they were working with just single cameras. And so there was this observation that it's better. And also in the back side, you see those white sheets. So if you reduce the noise in the background when you're training the model, that makes a very big difference in how the inference will work. So take care of these two things: constant lighting, constant background, and multiple cameras.
And I was actually going to ask what you guys think. So with my setup that I've got, I don't have a wrist camera. So there's the camera on the left is a wrist camera. It's like right on the arm.
Yeah.
I don't have a wrist camera. I've got an overhead and a side camera. Do you think that would be okay, or do you think I really need to get a wrist camera?
I think it would be okay still. Unless you have a really good environment setup. So this comes in optimizations for the environment and the training of the whole model. I think it would be pretty good as well, but this gives more information if you have a wrist camera as well.
Sure.
And this wrist camera also is very inexpensive. I think it's like 28, 25 or $30. So I mean, you can even add on without much overheads. So.
That's so cool.
Yeah, very cool.
Yeah, and then this brings us to our highlight robot foundational model, Groot. And this is what we also use to do training for our robotic arm as well. So the sponge, detecting the sponge, picking the sponge, and also wiping off the whole drawing that comes with training Groot. So we did 10 epochs. So that was the limit that we had at the moment for the hackathon as well, because we also got some credits, and Phosphobot, I think, only limits it to 10 at the moment. I don't know what they have right now. Maybe they have increased it, or if you go pro, you have more capacity to do it for longer epochs as well. But just a general information about what Groot is, it's an open source robot foundational model, and it's an action model as well. So it has a vision language model and an action model that are two separate actors in the whole architecture. The good thing is that it can, since it's a robot foundational model, we can fine tune it and generalize it across common tasks like picking, placing, throwing something, erasing stuff. So things like that, it's pretty generalizable to that. And we also saw that just with a few episodes of data, it's more than enough to train a considerably reasonably good model just in 1.5 days. And we will share the results as well afterwards of how it looks like in the final demo. But just so we created a data set of 120 samples as well. And this 120 samples is just basically using the leader robot to train, to collect data of how the follower robot will act within the environment, how it will pick up the sponge, it will erase the drawing. And then we did this over and over again. Obviously, it was a laborious task. And like Devang mentioned, that some of them had to stay back. This was the reason why they had to stay back, because they had to collect all this data for the model as well. to train it.
Overnight they were doing demonstrations.
Yeah.
Oh yeah. And I think for those out 120 demonstrations, on the one hand, it's quite tedious to even collect that many demonstrations. But if you look at how many demonstrations you need to train a robot from scratch, it is not nearly enough. You need thousands, tens of thousands of demonstrations. And that's what's so great about Groot is they've trained Groot on this combination of video data, synthetic data, and really teleop data. And so they have thousands and thousands of demonstrations of all sorts of tasks with all sorts of objects and all sorts of colors that they've trained this foundation model on. And it probably won't just do what you want out of the box, but with very few demonstrations like this, you can train it to do your specific task.
Yeah.
It's really cool.
It's pretty amazing as well. That just with a few data points you can do so much. And this also builds on top of what we are already discussing throughout the whole presentation, that it basically reduces the overhead for newcomers and aspiring robot engineers as well, that they don't have to go through a lot of data collection and a lot of tedious tasks that is always the case with training AI models. So this basically reduces the barrier for all of these people as well, and let them experiment more, even faster, and prototype even cooler projects in very less time. So
and when you combine this with Groot Mimic and with Groot Dreams, you might only need 5 or 10 demonstrations to post train the Groot Foundation model. So it's really, the barriers are getting lower.
Which is pretty good as well, and it's also open source, which is also very important, because a lot of people that don't have a lot of resources to basically break into robotics, just because there is a lot cost overhead as well. So having everything open source also makes it very easy for everyone to have access to all of this technology and to have fun with it, to bring out cool ideas and projects and all of these things.
And I'm seeing a few really great questions.
Yeah, I see that.
For you guys specifically. Two from Garv. He's asking, what library did you use for converting the coordinates to actual implementation? So I think he's basically asking what you used for your inverse kinematics. And it sounds like you're using that Phospho library. Is that right?
No, we will come to that point in the improvisation
later.
of the hackathon, because like we already mentioned in the start, not everything works in the hackathon.
Fair enough.
So you have to improvise a little bit from your original idea of how it works out. We will show this in the next slides, but if it's still
we'll cover it in the next slide then. No worries.
If it is unanswered, then maybe we can discuss this again.
Sure. And then he's also asking if you had problems when you changed the sponge colors.
Yeah, that's a good question, and I think it would be a problem, because environmental factors do really affect how the policy is trained. We did not test that. We were on a time crunch, so.
Well, you had just one sponge, and so you did not change sponge color. Yeah, and I think that's that's a comment we get sometimes is, well, how do you handle failure modes and edge cases and sponge? But I think for a lot of the more researchy projects and the more in the hackathons, I think you guys are just avoiding the edge cases, and you're just avoiding some of that stuff.
It work, but
which is fine.
But I have an experience that I can share from Arthur. I think he has experimented with it before, and because I think the wrist camera, it's grayscale, if I'm correct. So if the object color changes, then there is no knowledge about it. So I think that's in one of his observations he has mentioned it. So Arthur,
Well, and it also depends on how familiar Groot is with those objects, because sometimes Groot has already been pre-trained with knowledge of sponge, knows what a sponge is regardless of color. But I'm not sure. You'd have to test that, because I don't know all of the objects and all of the colors that they've used to train Groot, but they have been a lot.
But this also comes in the domain of environment optimizations, because generally what we have seen and what the community has also seen, that these learning techniques, they are very prone to changes in the environment. So you have to do a lot of stabilization in your environment to make it work for a specific task. I think that's also sometimes a drawback, because even a slightest change in the environment can cause a lot of problems in the policies. But I think there are a lot of ways to counteract that with the foundational model. So if, like you already mentioned, that if there is already a lot of information about what a sponge is in the foundational model, then fine-tuning it would basically just enhance that
Easier.
concept
Yeah.
for it. And then changing the sponge color won't be that big of an issue.
And then someone's asking if Groot and Grok are the same or different. And they are different. Groot is a robotic foundation model. So it's kind of like a base model that has general knowledge to make a robot work, but then you have to give it specific knowledge for whatever specific task you'd like to do with it. Whereas Grok is a large language model that's, I believe, built into X. Is that right?
Yeah.
Yeah. And then how many models did you fine tune? And is 100 episodes for one model or across various models? So I think you all had, well, how many do you fine tune? You only fine tuned the one Groot model, but then you also trained your own model for actually, was it an AI model? I guess your drawing was not an AI model. That was more of like you took an image generator and then put your own deterministic algorithms on top of that to let the robot arm draw that.
Exactly.
But and you gave it specific kind of inverse kinematic trajectories and just had it do deterministic trajectories. Yeah, cool.
Yeah. And coming to the question of how many models did we fine tune? So we had like a couple of versions of our models that we trained. So already you can see in the image that we had like wipe 2, wipe 3. So these are like more or less some experimentation that we did with some of the parameters that we wanted to change, and also the environment, just to test out which one works the best. So that's why we also wanted to collect data from just when we start the project on Saturday morning, because the more data that we have, the more models that we can tune. We have some configurations, parameters that differentiate between these models. And then we picked the best one that performed at the spot. So I think it was like 4 versions of our models that we trained, and we picked the best one out of it.
And then Arthur mentions that you guys did this with Groot N1, and there are newer models of Groot that are probably that might work even better.
Exactly.
I think the latest one at the moment is 1.5 and 1.5, and that is already being so that's also in Phosphobot as well. So this is our teammate Arthur Habuda.
Okay.
So he has a really good blog post for everything that happened in the hackathon, and also other posts as well in terms of foundational models, how to fine tune it, and how to do how to set up your SO arms as well. Really good resource. I think everyone should check it out. I think Edmar, we have a link for that as well. So if you can post that in the chat for other people as well, that would be really helpful. We also have a QR code at the end for his blog post, because that's the resource where everything is documented for our whole project. So that's the best resource to go to just see how the project worked out.
Cool.
People can also just scan the QR code.
And then Tom's asking about if you could use synthetic data to do random colors and sponge sizes. Absolutely. And Cosmos to generate some photorealistic images. Absolutely. And it's just, how much time do you have? I mean, you probably couldn't do that in a day and a half.
Because just setting up the whole Cosmos environment would probably take like a day.
But I think if you have a small team of engineers, can you use that stuff? You bet.
Definitely.
Absolutely.
Because Groot can handle that all obviously. Synthetic data, teleop data, and also video data should not be a problem at all.
But sorry, I interrupted a lot there. Let's continue with the presentation. We haven't even seen the final result video yet. We got to.
Yeah, now we're coming to the improvisation part. So Devan will take it away from here.
All right. Yeah, thank you, Swip. So, like we discussed, that it's such a short period of time, and you do plan a lot of stuff, but you have to give a working demo, and some of things may or may not work. So one of the things that a lot of team faced challenge with was the inverse kinematics of the LeRobot. And as much as we have investigated, we have realized that there is still not a very stable solution where you can have a desired coordinate and the LeRobot can follow that very reliably. So a lot of us that were planning to do something with inverse kinematics, which is one of the questions that Garv asked, if I'm calling the name correct. So then we had to improvise, and the improvisation that we did was that we used the voice prompt to basically define the features of a human face, and that's where the detective comes into picture. And then you can say what kind of the person looked like, what kind of eyes they had, or the face structure, or the facial features of nose and hair and all that stuff. And then we already gave some data set to the robot with different features. And then based on the information it received, it could pick most similar features and then draw the face out. And then that would be the part of the robot A, which we had to improvise for the demo. But the rest of it, with the training and with the sponge picking and drawing and erasing, it remains the same. So just one small improvisation that we had to do for the hackathon purpose. And yeah, let's take a look at the results.
Yeah, let me play this from the start again.
Not the audio, I would recommend. Because...
Okay, so yeah.
So for like a sample, I couldn't see him well, but this is what he looked like. You give them some verbal cues to the robot, and then based on your information, this is our DaVinci.
This is the robot DaVinci now. So,
It's so cool.
So cool. It does look like a suspicious person.
Eric, it looks like you. It's Eric. Busted. Oh, that's
So
amazing.
cool. And looking at working with that soft body. I mean, it's just I don't know how many people. I mean, I hope a lot of people appreciate how hard it is to work with soft bodies and how big of a deal that is.
I mean, it's still an active field of research because it's so difficult, and every soft body is different, and it's pretty hard to be deterministic with it. So it's pretty.
Yeah, it's hard to be deterministic, and it's hard to simulate it and do it with synthetic data, and it's just tough. And you did it. And
this is one thing that I had in my mind before coming to it, that one of the challenges that I want to tackle during this hackathon, I don't know about the problem statement, I don't know about what idea we'll work on, but we have to work on soft body. So I brought this sponge with me, borrowed it from a friend, like, give me the sponge. I want to do some robotics with it.
I like it.
Here we are.
Yeah, and this is our very organized table you can see in front of us.
Oh my gosh. I participated a little bit myself. I decided to sleep, and so I didn't make the top 30. But my desk I was trying to use, that was one of my biggest challenges, was just cord management. I had to go buy like Velcro cord things like 2 or 3 times, and my wife thought I was crazy. And what are you even doing? But I was just trying to like manage all the cords on my desk.
And we also, so our canvas, you can see from the picture here, we had a whiteboard, and then we had to tilt it and lock it in place so that the robot can draw on top of it. And it was just a mess.
People were walking like this from underneath the table. So we were the team with this flying canvas over there.
Yeah, everyone was bumping into it. Everyone was making like angry eyes at us. So what are you guys doing?
Oh gosh,
chaotic.
Amazing. I thank you guys so much for presenting and for the great links. We posted them in the chat. So, lots of people very excited and in awe. Very cool. I really appreciate you sharing every step of the journey here. We've created a thread for this on our Discord server. We'll post a link in the chat. So if you want to talk about this at any time, no matter when you're watching this live stream, you can go to that thread and I'll keep an eye on it and bring in developers as they're tagged. So thank you guys so much. We have the show's only halfway over. We got more goodness.
Oh gosh, sorry. Too many questions from me.
This is this is great. This is awesome. I knew this was going to be a really
I love this stuff. I love this
stream.
Stuff. Yeah.
Thank you so much as well. I'm gonna stop sharing now. So
okay, cool.
Okay.
Yep. Thank you for the question. Yep.
Well, thank you. We'll continue taking questions, and then we'll hopefully have some time at the end to take some more. if we didn't answer yours, if it was asked already. But now we have a very exciting Spice Terminator, which is sounds like it could be a movie. So Sanan and Pulkit, why don't you tell me a little bit about Spice Terminator and the origins and what you guys, how your idea evolved?
Well, actually, the fun thing is that we are also playing with the sponge in our project. But instead of cleaning the marker, we are cleaning the sauce from the plate. And we'll explain all the details in the presentation, but the idea comes from that. So cleaning sauce is not an easy task, actually, as it seems, because when you clean it, it tries to stick on the plate. So you have to do it again and again and again until the plate is all clean. Then you have to put the sponge back. And this was the whole idea. And this was the thing that we could manage to do in just under 24 hours.
Wow.
Amazing. Okay, so you're going to share your screen here. I'll put it up on the screen. So everyone, lots of great comments on the previous presentation here. I'll put some of them on the screen now. There's some Mehdi and Jesse, Megan, Lisa. Lisa had to comment twice. She's so excited. Okay, here we go. This is, okay, do we see your screen now? And your team was called Cracked Team, right?
Yes. So don't ask us why we chose Cracked. We don't also know that. We had only 5 minutes until the end of the hackathon. We just did it right in a random way. So yeah, let's go through the details. So it would be nice actually to get the questions at the end of the slides, because we'll try to explain more technical details about the fine-tuning, experiment setup, preparation, models, everything literally about the project.
Amazing.
So,
okay.
Firstly, who we are. So we are 5 random guys that we met in the Discord channel of the that is organized by the Hugging Face. So I am Sanan Garayev. I introduce myself actually, and I will quickly introduce my other friends. William is is the CTO of one of the companies. He has 10 years of experience with the software development. Bill is working with the Google DeepMind right now. He's a developer, and Atharva is the AI engineer, a research engineer at Epic Games. What did we do? You can also see the mess on our table. Well, we actually won 2 prizes. So a novelty prize in our Embodied AI Hackathon organized by SOTA in London branch. And we were included in top 30 winners list out of 250 submissions in the global LeRobot Hackathon organized by Hugging Face. And we achieved all these with the Spice Terminator that you can see on the image over here. So what is Spice Terminator? Spice Terminator, as I mentioned before, is a robot arm, basically SO101, cleaning sauce from the plate with the given language prompt. So I will show the demonstration very quickly, but then we will discuss about this later. So basically, you can see that in different types of plates, we are putting the sauce. There are some obstacles, some random objects, but still it tries to clean the plate. Okay, so this is not the only thing that we did. We also created a web user interface for our SO101 arm. This was basically the prototype, but our main idea was that to question about what software developers actually can do in robot learning area right now. So basically, there is a panel over here. You can control the robot, and when you control the robot in the Chrome application over here, in real time, it was actually moving the robot itself. So that was the idea, and we tested some stuff. So what kind of agentic workflows we can include, or what kind of how can ChatGPT can be used in this kind of systems, etc. And we will talk about it later as well. So yeah, overall, we will talk about the VLA models. If you are a beginner to this area, what are the VLA models? And how did we figure out the SO101 configurations? We did so much debugging actually during the competition. We'll talk a little bit about those stuff as well, the niche stuff that normally is not that taught in anywhere. And we will talk about the experiment setup and fine-tuning workflow, and finally running the inference. So what are the VLA models? Basically, quickly, the VLA models are kind of ChatGPT for robotics. So you are feeding video frames, language prompts, sometimes the robot states, and it generates the actions. Actions are tokens and like language tokens, and each token over there, for example, for SR101 arm, it was showing the joint state. So what is a Groot N1 or N1.5 model? Basically, almost like all the VLA models right now are working in pretty similar architecture. So it learns everything from the internet scale data, basically like using the pre-trained VLM models. And we are feeding the images, like video frames, to the vision encoder and the language prompt to the text tokenizer. It goes through the VLM, and after the VLM, we are using the diffusion transformer, which is coming from the imitation learning. Well, the idea of diffusion models over here is that, so in real life, the actions are not perfect. So this diffusion kind of models adds the noise levels in some steps, and the model actually learns for each noise level. So this is the main idea. And at the end, we are getting the tokens as like actions, mainly a kind of a list or NumPy list in Python. And we are feeding this to robot, deploying it to robot. So SmolVLA is also pretty similar architecture. They have a little bit difference in the attention layers. And the main differences are over here. So SmolVLA is the lightweight and fast model. Groot is high capacity and generalist, so it can learn so much stuff. SmolVLA is small. It is 450 million parameter model. It's designed and programmed by Hugging Face. And Groot is more like medium large. It's 3 billion parameter model. So it's getting pretty hard to fine tune it or train it on the PC. The SmolVLA is mainly for the simple tabletop tasks, and Groot can do so much complex tasks, including different embodiments like humanoids, robot arms, etc. So in the competition, we could make time to fine-tune both models, SmolVLA, Groot, and 1.5. Our idea was to compare those models if both of them worked. But unfortunately, well, although we got the checkpoints for the both models, we could only run inference for Groot model during the competition. So all the results that you will see in the other slides, they are mainly related to Groot. So the general idea of VLAs come from the LLM model training, basically explaining like ChatGPT-like models, LLM models, learn internet scale data in the pre-training phase. In this phase, actually, model is learning kind of grammar of the knowledge, like languages. So we are feeding like terabytes of internet data, random data to the models. They learn how to predict the next token in a sentence. In the fine-tuning stage, these LLM models are fine-tuned using the question answering, for example. In ChatGPT, chat means actually the chatbot version of the GPT. So GPT is the pre-trained model, and ChatGPT is the fine-tuned version of GPT for the question and answering tasks. And finally, they are using the RLHF feedback. For example, in ChatGPT, when you type something, you see two results coming at the same time, asking you, okay, which one is the right one? So you are choosing one. So this is the human feedback. Based on the human feedback, the model actually develops itself more and more. And VLA is pretty similar in the architecture or the training process. So in the pre-training phase, we have the VLM. So VLM learns the internet scale data. That's not a problem. But for VLA itself, we have the cross-embodiment learning data, especially basically any robot data in the world. So they are feeding all this stuff to the VLA model, and basically at this stage, VLA learns how to behave for different types of embodiments, different types of robots. But in the fine-tuning stage, we are using more clear data sets that we collected in the lab environments or in the houses. And we are fine-tuning the models based on these tasks. So this is very important because what we did in the competition, we used our SO101 robot. We had the task, and we didn't train everything from scratch. Groot and 1.5 was already trained on the like SO101 arm. So we fine-tuned this model to the specific kitchen task. In our case, it was sauce cleaning. So yeah, before starting about the experiments stuff, so how did we arrange the SO101 arm? If you want to build it from scratch, I can give you some tips and tricks over here. So there are two sides, SO101 arm configuration. So in this image on the slide, you can see our configuration. Basically, we have leader and follower robot over here. You can see there are two cameras. So we are using dual camera mode. So one is on top of the wrist joint of the robot arm, and one is on top of the table. So here, it's Intel Renaissance camera, but we didn't use any depth side of it. We just used the RGB. And these are our kind of setup. We have bowls, plates, sponge, and so on over here. So in the physical setup, basically, well, we did the physical setup first. And then we set it up the motors. Basically, there are some guidelines that I will show you in their website right now. So we calibrated the joints so that the follower and leader are at the same page when you start the experiments. We did the camera setup. Basically, we used the dual camera mode, and after that, we are using the full teleoperation. So if you want to try this on your own, well, there are so many guides from Hugging Face how you can actually buy or build it from scratch, SO101 arm. And in their documentation, you can easily find out if you have those parts, how you can assemble those parts all together, giving all the trips over here. So we followed the same stuff before the competition so that we was ready during the competition to code this stuff. So you are checking the ports over here. You are then you are calibrating the motors as shown in the video, if the video would work. But anyway, and there are some guidelines for calibration as well. So just follow this guideline to set your SO101 arm, and that will be enough to start with playing with this robot. So what is the next step? Next step is configuring the LeRobot environment. So this is our photo during the competition from the UI of the LeRobot. As you can see, we have over 2 different camera views. We were testing the cameras, so probably we dismounted the cameras from the robot. You can see dual camera vision. LeRobot is basically the main platform developed by Hugging Face to play with this kind of robots, not just SO101, also other kind of robots, and also run the policies or train the policies like imitation learning, vision language action models, etc. So they have pretty basic Conda installation. Make sure that you have Conda environment so it doesn't mess up with other environments in your PC. And I will show you their website as well right now. And yeah, the important thing was about this side, UI arrangement. Because, for example, in my PC, I was using Docker. So in the Docker, you have to give access to your GPU and give access to your screen, basically, monitor. So they have some guidelines for that. You should use some specific version of FFmpeg because in the background it's running rerun SDK, so it should be compatible. And yeah, at this point, to see the results of the AI models that you train in real time, there is a very nice platform called OneDB. So you basically create an account. It gives you some free trial, and you log into OneDB. And when you train your VLA model or different models, you can see in real time the model's evaluation or representation of the model. And yeah, at the end, if you want to work with the SmolVLA, just install the SmolVLA. So in LeRobot's documentation, you can, this is the whole documentation for the LeRobot. So there's an installation process over here you can follow, also FFmpeg version over here. And yeah, they have you can use just Windows as well. Just if you don't want to deal with Docker or Linux environment, that's not important. You can just install everything on Windows and start working there. Okay, so let's move on. Yes, now I'm giving the word to Pulkit to explain the experiment setup and dataset collection process.
Thank you, Sanan, for explaining all of the concepts. So moving on to more of what we did really. Next slide, please. Sanan, yeah. So this was what our setup was, and you can see there are a lot of stuff on the table, like the other team, and it also was like full of smell of glue and the sauce because we had hacked up on a fly the whole setup. So we had a RGB camera from the top view so that we can see the environment. Here we use Intel RealSense. Then we used a box to stabilize the camera, the plate, the bowl, distractors because we wanted to test the generalization of the model. And over here, the two black robots that you see, they are the SO101 embodiments. So there is a leader arm and there is a follower arm. And the point is that you can use the leader arm to record episodes so that the model can learn how the robot is supposed to move in a given episode. And along with that, we had some seat cables, adapters, stabilizers for the setup. Sriracha sauce, that is the most important component because if the plate is clean, we don't want to clean it again. And the wrist joint camera, that is kind of acting, that is sitting on the top of the robot. So it's seeing how the gripper is moving. Next slide, please. So data collection was one of the key tasks, and we collected episodes, like I said, using the leader arm. Here I am operating it. And we collected 75 episodes. Each episode was 25 seconds long. So to understand this, what helped us was that we went through a lot of the other data sets that were recorded in previous hackathons. So there was a Mistral hackathon, which also was around these embodiments. And from there, we understood what kind of, how to collect data set and what kind of data sets we want to collect. So the main prompt that we gave to the model was that we want to wipe red sauce from the plate using sponge. Now, for a task like this is fairly ambiguous because you're not telling where the sponge is, how the environment is. It has to learn all of that from the RGB streams that are getting it. So we wanted to create so many examples so that the model could generalize to some extent. And this is where the whole challenge lay. So when we are fine-tuning models, it has to, we want to give some constants, and that would be the plate, the lighting, and the environment. Whereas we want to introduce a lot of complexities into the environment when we add different things. And there are some tips that we want to calibrate the robot arm very carefully, and Sanan was an expert in that. And it's also easier to control the robot with left arm. My fellow teammate Bill was very proficient with that and helped us collect a lot of samples very quickly. I, on the other hand, struggled. In fact, it was very different how the gripper, we were like, when I was operating, I was picking the edge of the sponge and then cleaning it. Whereas, when Bill was recording the episodes, he was picking up much more efficiently. So there are a lot of ways, areas where variance could come, and that's what we saw. And then we collated all the data sets using Phosphobot, and here's the dataset link. Next slide, please. So here we'll quickly show you some of the episodes that we recorded. So to create generalization, we moved the plate around. We wanted to keep adding sauce, and for the robot to kind of generalize to it that, okay, new sauce is added. So there are new aspects that it needs to take care of. So this is how and then we also littered the environment because the task was to just clean the plate. So that's what we were going for. Next slide, please. Coming on to model fine-tuning workflow. So over here, we worked on two models, SmolVLA and Groot. And for SmolVLA, we fine-tuned them on our local system because it required a lot less VRAM. And we used the default settings for LoRa adapter and frozen VLM model. And it worked with the RTX 4060. It took us a while to get to set up the environment, and it was not that easy to get things working. But it helped us. But it only took 3 to 4 hours for 25 samples. And to appreciate how great this model is, in fact, these things generally require very heavy GPUs. But SmolVLA for very small kind of testing and not generalizing a lot does work well in this scenario. And we had a total of 20,000 steps that we trained. Next slide, please. Groot, on the other hand, is what saved us and gave us that extra generalization capabilities and gave us that push that made a project a gold medalist. So it required more than 20 GB VRAM, and we got cloud GPU access. So Ori is a GPU provider, and we got access to an H100 GPU. And with that, we could train it in 1 hour. So we again used default settings, LoRa adapter, and it was very seamless again to set up everything and to get it working. Athar was the key to that. He sorted out everything. And we trained on again 20,000 steps. And we use a new embodiment setting. So again, Groot can be used for any embodiment that are there. It just needs to be fine-tuned for whatever setting you want to use. And that's what we did for LeRobot for our embodiment. Next slide, please.
Well, yeah, at this point, I would like to just quickly add one thing. So as you see, it took just 1 hour with H100 GPU. And even if you are like hobbies or developer or the company, well, the cost is always important when you train the models, especially in the cloud, because you are paying money for that. So the best thing actually about Groot is that we trained this model with some kind of like some amount of success rate that we will discuss, but it worked for one task for less than just $3. So that is, I think, the great thing of these kind of models and modern research actually on the efficient fine-tuning methodology like LoRa or other methodologies.
Absolutely, and you can even use Colab to run some of these models. And as and more efficient these models get, we'll be able to bring robotics to more and more people. Next slide, please.
Yeah, just before going to the inference side, I will just show you if you probably want to train your SmolVLA model. So, well, Hugging Face has very nice documentation about the SmolVLA fine-tuning, starting from the installation, also some tricks about the collection of the data sets. So we also followed these guidelines. And NVIDIA has a very nice blog post on how to train Groot N1.5 for LeRobot SO101 ARM. That was just released actually 2 days ago, 2 days before the competition. So we were lucky during the competition to have this resource. And we followed the guidelines over here. They are also teaching how to create an environment, test the cameras, collect data, see the results, basically everything about the fine-tuning of the Groot. So yes, let's move with the inference side. So, well, on the inference side, the key thing actually that we will show is the generalization ability. So before going that, well, in the how did we run the inference and what was the problem over there? So we use the cloud to reach the GPU clusters to train our model. So, well, until you get the checkpoints, everything is okay. If you prepare your model very well, if you upload everything over there very well. So everything is very nice. But during the inference, we had the question actually about, so robot is the physical system. We are using the ports, but the model is in the cloud. So how we can actually give the cloud an access to the ports? So that's the question that you have to handle when it comes to model inference. We basically asked this to ChatGPT, and it gave us some guidelines, just followed, and it worked very well. So yeah, make sure that well, if there is a problem with running, so make sure that you get this connection very well before testing. So we tested different prompts to test if our model actually can do some other stuff as well, other stuff that we taught the model. And we test some generalization prompts, like generalization tasks, and we kind of evaluated the success rate. We ran it again and again and again, and so each time, if it works very well, what happens when we add more souls, etc. Yes, Phuket, I think you can talk about this stuff a bit.
Definitely. So thank you, Sanan, for leading that. So we used a cloud-based Groot inference with a 16 action window. What does that mean? We'll get to it. But like I said, the inference location was not with us. It was on cloud using an H100 GPU. And what we mean by action window, which I'll explain in a bit, is that we were predicting 16 actions per inference. So it was not that there was stream of actions that were coming. but rather we were chunking the actions in one go. And the reason for that was that cloud inference typically has 300 to 500 milliseconds latency, and if it was a stream, it was not working really well because it was getting confused in what action to follow. So this one was encouraging stop and wait behavior, and which is why if you see our results, the robot moves a bit jankily and not in a very smooth manner. And for the sake of the hackathon, we did not explore how we can improve that. Next slide, please.
Yeah, at this point, actually, I would like to show some inference result, but after that, we will move on more on the what is the difference between synchronous and asynchronous inference. So basically, our results were like that. So this is the wrist joint camera. So as you see, it tries to grasp the sponge and tries to clean the sauce. It's pretty nice, actually, in this video. And put it back. So that was also our language prompt. Basically, we gave the prompt like, take the sponge, clean the sauce from the plate, put the sponge back. And at the right side, you will see the real time without adding any extra, it's not 2x, 3x video. It's just originally how this robot works. So it's pretty slow, as you see. But yeah, at this point, we put the source before the task. Now we are changing the condition. We are adding more sauce at the other side of the plate. So firstly, it tries to clean the place that we put the sauce. It will take a while. Yes. But instead of going to the bowl, it sees that, oh, well, there is more sauce on the plate. So I have more stuff to do. So it tries to reach that coordinate of the sauce and try to clean it. So let's see. It's so slow, but
yeah, we were also waiting with our breaths held if it'll go on.
Yeah. But at the end, yeah, it tries to clean it. So this stuff actually comes from the language grounding ability of the Groot models. And this language grounding is actually coming from the VLM. Because when it sees from on the top view, the table, it can easily recognize, it can basically use the object detection over there. So it's automatic system. It's not that we didn't use any object detection methodology over there, but it can identify where is the sauce, where is the plate, where is the bowl, and then the diffusion will give us the actions that robot will perform. So yes, and we tested the generalization ability of the model. So here, during the competition, we had some meal. They sort of provided us so much nice meal with the carton plate. So we thought that why don't we try with the new plate, like carton plate? Because in the training set, we only worked with the ceramic plates. We didn't use anything different. But in the inference, we put the carton plate. And as you can imagine, there is a dynamics mismatch between the ceramic plate and the carton plate, because when you try to clean the carton plate, it tries to move away. So the robot's movements should change in that way as well. So it's very, very hard task for the robot to do that. So let's focus on the left side for now. So as you see, even if it's carton plate, still, even if it moves away, it still tries to find the source and clean it. That's also the best thing about the language grounding stuff. And yeah, it tries to put the sponge back. A little bit is getting laggy over there. So let's focus on the other side. So we added more source, as you saw in the previous video. This is quicker version of that. And we use some distractor objects like Red Bull can, for example, fork, knife, basically different stuff, so that we wanted to understand if it really understands what the sauce is. Because maybe if it sees like literally anything on the plate and thinks that, okay, this is also sauce, I have to clean it as well, something. But it worked very well. So yeah, but not everything is live is great. Also, not everything is about the robotics is great and AI is great. So we had the failing situations as well. So for example, here we are, that it's the same prompt, but it tries to get the sponge again and again. But as you see in the actions, actually, it cannot grasp the sponge very well, because we added some actually soap on it a little bit, and it gets, its dynamics is changing a little bit as well. But yeah, but here, for example, we are trying to cleaning the plate, the sauce, but yeah, it doesn't go back. So that's also one of the cases, failing cases. So we try to move it away, move the plate away, so that, but still it doesn't work like that. But anyway.
So to jump in really quick, this is what basically, can you like go back to the previous slide, please? So this kind of elucidates what exactly is the challenge of the problem that we designed, is that there are three parts to it. So here is unable to grasp, because this is a grasping problem, and it needs to grasp in a way that, you know, it's able to meaningfully clean it. The second part being that it has to identify the source and then clean the source accurately. And the third is to go back to where the starting position is. And if you see, the robot then actually goes back into the rest position and looks like a very cute puppy. I don't know why. But the point is that there are a lot of aspects to the whole problem, which seems very trivial to us as human beings. So to help the model understand all of this and to learn all of that just from recording episodes, that is what something that caught us off guard. I mean, we were surprised that it was able to follow so well. So doing these three different actions, which are very trivial, and to grasp and to pick and to clean and to go back, and sometimes I forgot to add the video, but it sometimes also picked the bowl in which there was the sponge, because it was trying to grasp a sponge, but the orientation of it made it slip, so it picked up the whole bowl, and we were scared for our life. So that's what really elucidates the whole problem of physical embodiments and learning with physical embodiments, that you need to outline the task really well. So yeah, that's what we want to talk about. And next slide, please. So yeah, so now that you saw our results, quickly we want to discuss about asynchronous and synchronous inference. That is something that we came across. So like I said, synchronous is stop, think, and act. So it waits for the predictions before moving. And we get very stable and deterministic tokens, and on also how the model, the joints should move. But like we said, it becomes really jerky and very janky. So it's not moving nicely. It's going like this, which is not great. On the other hand, asynchronous is amazing because it keeps moving while inference runs in background. So you get a nice stream of actions, but it might act on stale observations, and it might be harder to debug, basically understand why it's failing. So which is why for our task, because we were getting some latency from cloud, we chose to go with synchronous inference. Next slide, please. And now let's talk a bit about the web UI integration. So is the audio, can we, okay. So basically this is what one of our teammates, Bill, mainly worked upon. So here is the web UI integration. And what you see over here is that we have kind of replicated the whole setup on the web user interface. And you can interact. So if you don't have a, for example, a leader arm to train, you can interact with it and you can train it from the web user interface. And once you have trained it, you can actually do a lot of interesting agentic workflows, or you can use the power of all these amazing agents that are coming across, where you can just use your voice prompts or text prompts to see, and you can monitor that way. So you can imagine something like this in a very huge commercial kitchen, where you have thousands of these bots cleaning plates, and you can monitor that from your own office. And that was how we can extend the whole DevOps part of it on a web user interface and develop more of it. And this is very, very important because you want to constantly measure and see how these robots are performing and what these robots are doing, and also train them, which is what one of the panelists talked about, is that how less support there is. So these kind of interfaces actually give us that support to train the model and also monitor them and train them actually more efficiently, instead of just training them in with a leader arm that is kind of stochastic in a way that everybody has a different way of cleaning.
Yes, and one quick thing, if when we move this robot over here, the real follower robot is also moving in the same
Yes,
way,
yes,
because we are
absolutely.
sending the actions to the physical robot as well.
Amazing.
And that's all. Thank you so much.
I can't. This was every slide was very informative. I want to thank you both teams for putting together such great, thoughtful information. I think it was really impactful. We're getting a lot of great comments, some good questions too in the chat. So Eric, I don't know if you want to go through some of these that you think would be the best ones to hit here. We've been sharing links along the way. Big thanks to Amelia, who's been eyeing the chat like a hawk and posting links in real time. But Eric, what do you see here? What do you want to tackle first? There's some great. I mean, both projects are really cool. It's actually really interesting that you guys both used sponges too, and both
Yeah.
successful. That's really cool that you guys did that. But what do you think, Eric?
Let's see. I think a few.
Meanwhile, I have a question for the Spice Terminator.
Oh, sure.
How much sauce did you guys use?
Don't ask, because
That was the only thing I was also thinking. How much sauce did you waste?
And I was thinking, how many times did you wash the sponge? Like, how, that's also a task. You have to consider the effort going into that.
Actually, that was quite poetic. That was like an orchestra we had, because me and my and our teammate Bill, we were working to collect the data sets, while Sanan at that time was figuring out how to make SmolVLA work. So we were taking turns. So one guy was just washing the plate very quickly and getting stuff ready, and the other guy was just waiting at the leader arm. And then we said, okay, go for it. And then he's cleaning that plate with the leader arm. So it was like complete orchestra going on there, and we were really tired as well, but we had to get it working.
It's ironic that you were teaching robots to clean plates, but you cleaned more plates.
Exactly. And we were clean, and because we were like constantly cleaning it with tissues, and we were also cleaning the sponges because they used to get red very quickly. I mean, we recorded 75 episodes, and by the end, whenever some judges were coming into our workspace, we were all smelling like sriracha sauce. It was really terrible, but they were also amazed to see it clean, so we were happy.
That's awesome. That's a question I think was on all of our minds. So thank you for asking that. We have a question from Pierre on LinkedIn.
I think if my wife is watching, she'll buy me one of these robots so that either I wash the dishes myself or I teach it to wash the dishes. But either way, the dishes
Win-win.
get washed. That's right.
Yeah,
All right,
and
what
you
platform-
monitor from your office,
What platform? Pierre's asking, what platform you guys use for the GUI?
So this was an open source GitHub implementation that was there. So we basically built upon the SO101, and we basically connected our robots to that.
Oh, I think he's asking about that web user interface.
Yeah,
you're
the
talking
GUI.
about.
Yeah, I'm talking about that only. So there's an
So
open
what-
source implementation upon which we built.
But is it like JavaScript, or is it what do you use?
It was
to-
Python.
Python. Okay, cool.
Amazing.
Let's
Okay,
see.
cool.
Could you use Replicator? So
No, this was running locally.
yeah, and I think there are a lot of questions. I'm seeing quite a few about edge cases and kind of failure modes and recovery. And just keep in mind that this was a day-and-a-half hackathon, and they were really just avoiding those edge cases, which is the right way to go for a day-and-a-half hackathon. But could you use Replicator and domain randomization and synthetic data and Cosmos to help out with those edge cases if you're doing more of an industrial grade project or an industrial grade dishwasher robot? Absolutely.
Absolutely. I mean, like I
Yeah.
said, first thing what we wanted to do was keep some of things constant. So that was the lighting and the environment, like how the plates are kept and everything, because you need to fix some things, right? You can't ask the network to hallucinate everything. The less you ask to hallucinate, the better it is. So some things you have to fix it. However, we added a lot of abstractions. So we gave it like around 25-30 episodes of exactly the same thing so that it understands the task, right? And after that, we designed episodes where we are pouring sauce while it's cleaning. We are taking away the plate. We are adding more obstructions. We are blocking the view, things like that, so that it understands that, okay, if these things happen, it's okay. We can still clean the plate. So
Right.
so that was how we were creating domain randomizations. And on top of that, we were also thinking, so like I mentioned, there was a Mistral hackathon, I think a couple of months before. And they also attempted a similar task, but it was much simpler. Like they had a solid object and they were just kind of kicking it out. So we were wondering if we could include that as well to give more understanding of the task and to give more domain randomization, as you said. So
Was that
definitely,
helpful?
no, we didn't add that again because the
Oh,
environment was totally different. So
got
that
it.
would actually confuse the model. So in
Okay.
fact, I've read somewhere, I think some of the big guys were talking about that the correct data is far more important than algorithms at the moment, especially
Hmm.
with robotics and robot learning. So you really need to invest a lot of time in creating that data and creating it in a very meaningful manner in the way the robot actually learns positively and doesn't get confused.
Yeah. Yeah. Absolutely.
And
Let's see.
if I
There's.
may, sorry.
Oh, go ahead.
uh, I I don't want to interrupt you, Ishwan.
Oh, all good.
I was just saying, like having worked on a similar problem statement and facing with similar hardware, I commend the number of variations your team tried to bring in that 1.5 day time frame. It's incredible. It's giving me
Yeah.
goosebumps because we were trying to keep things as standard as
Mm.
replicable as possible, and then there were you guys were completely like trying to bring in this object and that object in that short time frame. And I want the audience to really appreciate how bold that move was, and I commend all of your team to really try to pull it off.
That's awesome.
Thanks
Very
a lot.
Yeah, that's a really good point. I mean, they had different colors of sauce, different shapes of sauce, forks, different types of plates. They really included a lot. And I guess you even mentioned moving the plate while it was trying to clean. I'm sure the robot did not like that.
Actually, here's a question from Arthur, which brings up another point. Also, I was going to ask. He's asking, have you followed any specific resources on how to run inference from cloud compute? And I was thinking the whole time. Actually, I was wondering how each of you actually, what was your journey in learning how to do what you were able to do? What kind of resources did you use? That you find most helpful in helping you to get where you are today. You're able to be. What would you recommend other people do for learning? But answer Arthur first if you want.
Sanam, would you like to take over that?
So in the cloud compute, actually, or clouds will provide so much stuff in a much easier way for us to train our model. Well, actually, yeah, we split the tasks during the hackathon. So, for example, for web UI, Will was responsible for cloud computing. Atarvo was responsible. So I'm not exactly sure what steps we followed at that side, but Atarvo said that, Ori lacked a little bit documentation about that. So we had to build everything that we built on our Windows platform in the same way in the cloud service.
Great. And then the broader question of where each of you developed your knowledge, where do you find most helpful in terms of resources? Do you rely on documentation? Have you taken online courses, or are you following any certain blogs or communities where you've learned a lot? Where do you recommend other people?
So, okay. I'm actually doing my dissertation on vision language action models right now. So I read so many papers. That's why when we started the competition, but for my side, I was very knowledgeable about how the system operates, if we can do it under 24 hours or not, these kind of details. But I think, yeah, the resources that I showed during the presentation, the Hugging Face, all the basically documentation through the Hugging Face, and that Groot models documentation. It's still in the Hugging Face blogs. They are very, very, very useful for anyone with no knowledge about this stuff to start from scratch and work on these platforms. Especially, it would be very, very nice if you can order or make SO101 ARM as a first point. Then you can try anything you want with the SO101 ARM. There are also so many open source projects as well. You can check the GitHub. But for research side, if you're interested in that side, there is a team from UC Berkeley under supervision of Sergey Levin. They are mainly the mastermind of this kind of VLA models. So they have the main paper called OpenVLA. And Sergey Levin also has a company called Physical Intelligence. So they already deployed these kind of systems in the Airbnbs. And they said that well, they trained the models in the lab conditions, but they deployed the model in random Airbnb, and they said that they have very, very good generalization ability.
Wow.
So I would prefer you to read to understand the core model, all the training process. They also tried so many different fine-tuning methodology, and they said, okay, LoRa is best. You can find everything in OpenVLA and Pi0 papers. Also, there is very nice research. It's very recent from Toyota Research. It's called Large Behavior Models. So here they mention about the data collection process more, like how you can make the distributed tasks. Also, how little tricks like data normalization can actually enhance the performance of your model very well. It's very basic, like simple trick, but yeah, it can boost the performance of the model from 10% to 40% success rate. It's huge.
To add
Very
on to
good.
what Sanan said, basically, so I would first of all like to give a shout out to all of our teammates because Atharv and Bill had these embodiments and they had built it from scratch, and like they had ordered the parts and they had done all the hard work, so they had some experience with it, and that helped a lot. Sanan had experience with working with VLAs. I came in blind, but I had some experience with 3D vision, and that's my bread and butter. And William, on the other hand, brought a whole different perspective, and he was the one of the most influential members of our team because he was managing all of us. So he brought in his expertise of managing teams, and we had OKRs set out, and that actually helped us manage time. And also he built the whole web UI interface, and all of this worked really well together. So even if you do not have any experience with robotic, I think that's a really good thing because you come in very fresh and you have no biases working for or against you, and you see the world in a slightly different way, and that helps a lot. So also the Hugging Face hackathons that have been happening, like the Mistral one, I would recommend always going through what people have already done or what have they built to get a sense of what basically you can do. That may not be always there because there were some teams in the London hackathon who had built some amazing stuff, things that I didn't even imagine was possible in 24 hours. But there were some really amazing teams in London hackathon. So, but luckily, like Sanan showed and pointed out, the Hugging Face documentations were really well written and very easy to understand. And Phosphobot, another thing, we use it only for data sets, but like the other team, it is like really easy to set up and really easy to work with.
Great advice, great suggestions.
Yeah.
And so Hebe and Devang, any suggestions from your end?
Yeah, I think building on top of what the other team, Pultik and Sanan has already said, I also recommend for newcomers, novice, robotic enthusiast people to also go through the NVIDIA Deep Learning Institute courses that are the free ones. I think they're pretty amazing. They also let you introduce you to a lot of simulation-based robots as well. So if you don't even have hardware, you can use Isaac Sim, platforms like Isaac Sim, Isaac Lab. They give you a lot of good fundamentals as well. You can basically manipulate robots, control robots, train policies within the simulation environment, and just get a good idea about how everything works. So I think this is a really good resource, not just for arm robotics, but also mobile robots, and also anything robotic operating system related, ROS related, anything that you want to do in the space of robotics in USD. So that's a really good resource for people who want to break into the industry, to want to learn something, and they don't know where to start. I think that's a pretty good resource paired with the LeRobot documentation as well, and also their projects. I think then you can have a really good idea about what you want to do in that domain.
That's a great suggestion.
Yeah.
And from my side, I think the resources have all been covered. I won't add much to it, but I would give just an alignment or the thought process for you to work with, that if you would look in robotics nowadays, a lot of jobs are opening roles like robotic simulation engineer. You know what it means, that you can actually do full-time career path just based on simulation. So that is something which is relatively easier to learn. You don't have to wait to have some hardware, and then that's not an excuse anymore that, hey, I don't have anything to learn and to work with. So there is resources out there. All you need is a computer, and then you can start learning. So do not wait, do not feel shy, start learning already, do simulations, get yourself groomed, and the market out is like waiting for you, for all the students out there.
Great advice indeed. Of course, we have a wonderful community of developers that are meeting regularly on the Omniverse Discord server. There's a Isaac Sim and Isaac Lab study group that meets every Wednesday. We have an OpenUSD study group. By the way, the OpenUSD certification is now live. So people who want to get an official badge, you can go ahead and get officially certified by taking an exam. I'll post the link in the chat right now. Highly recommend for anyone who wants to learn more about OpenUSD before you take the exam. You could take, there's a similar learning path that we posted earlier about robotics. There's one specifically focused on OpenUSD. There it is in the chat. You could also just do a search, Learning Path OpenUSD or Learning Path Robotics, and you'll find them really quickly online. Highly recommend those. This has been fantastic. What an amazing, almost 2 hours now, but chock full of information. I want to thank each of you for spending the time to share all your learnings and your celebration from the LeRobot Hackathon. Let me ask you, would you guys do it again? The next hackathon? Yeah?
Definitely.
No hesitation. Would you use a sponge again?
Yeah. This time we're going to go with shirts, like doing something very more challenging.
Oh, that's awesome. Yeah, very cool. Eric, what was your what do you take away from these presentations? What do you?
I'm just amazed at, well, as this once again, I mean, some of these projects a year ago would have only been possible by, people in kind of elite research groups, or at these elite robotics companies. And now strangers are getting together, and in a day and a half, and they're people with some mixed backgrounds, some of them with backgrounds in robotics, some of them are doing research in the area, but this is not a whole team of PhD researchers and postdocs. This is a lot. The bar has really lowered significantly, money wise and resource wise and community wise. Just if you're interested in robotics, it's hop on in. You can join us.
And one of the great places I learn a lot from and meet a lot of really interesting people is also just on LinkedIn. See a lot of great developers, a lot of great companies that have been sharing information. Here's one that I just saw the other day, and I've been chatting with the CEO from Worker Labs. They just released a nice tutorial. I'll post this in the chat also. Really good tutorial, real-time drag and drop layout for designing your industrial cell visually instead of writing code. So they have a tutorial that shows you how to do all that. Workers Lab, they've been posting some really great content, and their goal is to simplify the experience for all developers and leveraging Isaac Sim. So really helpful company there to follow. I'll post a link in the chat. I also saw a really cool post from this other great team, Robots for Humanity. They've been also producing great content here. I highly recommend you follow them. They've got a really cool event coming up too. I believe they're going to be presenting all their work on November 7th at AWS in San Francisco. So I would follow their page as well, especially if you're interested in humanoid robots. Here they're celebrating some work leveraging NVIDIA Cloud XR. So I always find really great people to follow, and then you just as the network gets bigger and bigger and bigger. Yeah. Obviously, I recommend that everybody follow the developers on our panel today. You guys have been really producing some fantastic content, and I just think it's so amazing. What a great quality to have as a human, to put the effort in to share your knowledge and learnings with other people. I just think that's amazing. Not only in the writings you've done, but preparing everything for today. So thank you all for doing that.
These are all friendly. These are all friendly people. All these people you're talking about, Edmar. All these people, Edmar is friendly, and these groups on LinkedIn, and these you guys.
It's a great community. It really,
Yeah.
I've worked with communities before, but the robotics community, developer community, just seems to be so supportive. It's just an amazing, positive. Everybody is trying to help each other, and move everything along. I think it's just amazing. And thank you all for everybody watching. Some great comments throughout. Some regular viewers I see joining us today. Really cool to see some new faces also. It's been really fantastic. We're going to head out in a minute, but when we come back next week, we will be on our live stream again on Wednesday at our normal time, 11 a.m. Pacific. You can go to our Add Event calendar, which is in the chat right now, to find out all of our next upcoming live streams, our OpenUSD study group, our Isaac Lab study group, our office hours. They all posted up on our Add Event calendar. So I highly recommend you check that out if you want to keep up to date. Everybody says, hey, where can I find out the next live stream? It's the Add Event calendar. And then all of our live streams are available on the YouTube channel. So if you just caught the tail end of this one, you can watch it right away on YouTube. Just go to the live area on the Omniverse channel and you'll see it. Thank you all once again. It's been fantastic. What a great couple hours.
Thank you for giving us the opportunity. It was a pleasure being here.
Thank you for having us.
Yeah,
Thanks
best
a lot.
of luck to you. Hope to have you on again to talk about your next project.
Yeah,
Absolutely.
definitely.
Sponge or no sponge? Yeah, bye, everybody.
Yeah, everyone.
Yeah.
Bye, everybody. Take care. Thank you.